Right, guys, I'm going to get started. So, hello everyone, I'm George. I'm a third year computer science student. I've been using LÖVE to make games for about 4 years now. I think making games is fun, and I think LÖVE is a really great tool. I wanted to share that with some people, so thank you everyone for coming. So, what exactly is LÖVE? So, also known as LÖVE 2D, LÖVE is a framework for 2D games. So it's not quite a game engine. It's not going to provide you with an editor or an idea of a scene or a camera or an entity like game engines like Unity would. But it gives you a fairly basic set of functions with which to program your own game from scratch, essentially. So you program in LÖVE. LÖVE is a scripting language. It's interpreted, it makes use of just-in-time compilation, so it's pretty fast. It's lightweight, it's extensible, and it can interface with other languages like C++, for example. So LÖVE can call C++ functions, and C++ can call LÖVE functions. So as a result of this, it's one of the most commonly used scripting languages for games. So it's not a bad language to learn if you're interested in game programming. So LÖVE itself is written in C++. It's open source, you can go and have a look at it, you can go and contribute to it if you like, and it's cross-platform, so you can develop on any device you like and distribute on any device you like. It's really, really easy to do. So I think it's really easy to use. I think that's the most important point. And fundamentally, I think it's great for making games quickly. So perfect for prototyping or for game jams, for example. So I'm going to start by showing you a demo game that I've made in LÖVE. This is a game that I made in a couple of hours using freely available assets. And the source for it is available in the notes, which I'll show you in a minute. So it's called Zombie. It's a kind of arcade-style game. You control a character who can run around. And as you'll see, there are zombies in the game. I'm gonna deliberately die. I could go for a lot longer. Okay, so this is just a quick example of a game that you can make in just a few hours using LÖVE, and I wanted to show you that it's really quite easy. Okay, so let's actually get started. Today we're going to make a small game ourselves. The idea is that I'm going to demonstrate stuff on my laptop and that you guys can follow along on your laptops. I'll try and give plenty of time for people to follow along, and I'll also try and keep all the code up on the screen so that if at any point you're trying to choose between copying down what I'm writing or listening to me, then listen to me and then copy down afterwards. Okay, right, let's go. So let's download and install LÖVE 2D. So open up a browser, head over to love2d.org. This is what you should see. Go and get the version of LÖVE for your platform. If you're on Windows, grab the 32-bit zipped, not the installer, just the executable. Obviously, if you're on OS X, you've only got one choice. If you're on Linux, there are some more instructions for you in the workshop notes. To get to those workshop notes, I'm going to show you one more time. That is the link to find all of the notes for this workshop. So grab the version of LÖVE for your platform and download it. So I'm going to show you what I've done. I've just grabbed the zipped version for OS X. I've got it here on my desktop. I'm going to unzip it, and I'm going to get a .app file called LÖVE. I'm going to delete the thing that I unzipped. And if you're doing this on Windows, you should unzip that zip file, and you should find an executable called LÖVE. And you should do what I'm about to do, which is run this. And when you run it, you should get this screen, no game. So we're going to move on once everyone has got that screen on their laptop. Okay, so we got a no game screen. That brings us on to the point of what is a game with LÖVE. And it's really simple. It's just a directory. So the reason why we got a no game screen is because we didn't give LÖVE a directory. So that's what I'm going to do now. I'm going to make a new folder on my desktop. I'm just going to call it game. And to run this game, I'm going to drag and drop it onto the executable. And now I should get a different screen. This time it says, I don't know if you can read that, it says no code to run. And that's because the directory is empty. There is no code inside it. So you can, whether you're on OS X or whether you're on Windows, you can run your game just by dragging and dropping. I'm going to be doing this through the terminal because it's easier. You can do it through command line as well. But dragging and dropping, super easy way of doing it. So no code to run. So to get some code, I'm going to make a new file. So I'm going to open up a text editor. This is what you should do now. Go and open up a text editor. And we're going to make a new file inside the directory we've just created. And we're going to call it main.lua. Right, main.lua. And once you've got that empty file in the directory, and you run that game by dragging and dropping, you should now have a black screen. Okay, right. Does everyone should have the black screen? Has everyone got the black screen? Perfect. Right, we're ready to actually write some code. So, I'm going to start editing this file that I've just created called main.lua. And the first thing that I want to do is just draw something on the screen. Okay, so first thing I'm going to draw is just a rectangle. To do that, I'm going to start writing a function. This function is called LÖVE.draw. So this is how you write a function in LÖVE, a keyword function. That's really hard to see. How's that? Okay, keyword function, name of the function, pair of parentheses, followed by end. Okay. So we're writing a function called LÖVE.draw. This is actually a callback function. So the call site for this already exists somewhere else, and we're just going to implement what that function does. So what we're going to put in here is a function call to draw a rectangle, and that function is LÖVE.graphics.rectangle. Okay, so what are the arguments for this function, LÖVE.graphics.rectangle? So the first one is fill. That tells LÖVE to fill the rectangle with color. And the second one, actually I'm not going to tell you what the others do. I'm just going to write them in. Okay, so we've saved this file with this code in it, and we're going to run it. I'm going to do like this. And when you run it, you should get a window with a white rectangle inside it. And once you've done that, try changing the numbers to figure out what they're doing. Okay, so if you've tried changing these numbers a little bit, I hope some of you will have worked out what they're doing. So these first two parameters here are giving the position to put the rectangle on the screen. And these last two parameters are providing the width and the height of the rectangle. Okay? And something you'll notice is that this number here, the y position, is actually working from the top of the window. So you might be used to axes where the y goes from the bottom, but with LÖVE, the y goes from the top of the screen. So we can change this and put the rectangle in a slightly different position if we like. Okay, so this function, LÖVE.draw, is a place where we're going to be writing all of our drawing code for our game. This is a function that we'll come back to a lot. Right, let's do some more drawing. Rather than having a white rectangle, let's give the rectangle some kind of color. So to do that, we set the color. So we're going to call this function love.graphics.setColor. And we provide it with the color to use in just RGB values. So I'm going to say 255, 100, 100. So each of these is the red, the green, and the blue to use from 0 to 255. So when I run this, I should get a kind of reddish rectangle. So the way that love.graphics.setColor works is that every draw call after setting the color is going to be using that color. Think of it like dipping a paintbrush in a paint pot. So if I drew something else, that would be the same color, right? So that's what I'm going to do. I'm going to draw something else. This time I'm going to draw a circle. So that's another function called love.graphics.circle. That's not how you spell circle. So I'm going to fill this one with color as well. Actually, no, change my mind. I'm going to make this one outlined. So to do that, you use the string line instead of fill. So I'm going to outline the circle, and I'm going to put it at x position 250, y position 250, and I'm going to make the radius of the circle 56. Okay, so you can see it's kind of overlapping with our rectangle here. It's a bit unclear where the circle is and where the rectangle is. So I'm gonna make the circle a different color. So I'm gonna set the color to something different. This time, let's make it blue. So there we go. We've got a blue circle on top of the red rectangle. And when I say on top of, that's kind of important, right? Why is it that the circle is on top and the rectangle is on bottom? It's because we called the function to draw the circle after we called the function to draw the rectangle. And that's how draw order works in 2D. The thing you draw last is the thing that ends up on top. There's more stuff I can do with drawing. I can set the background color to use. So that's what I'm going to do. I'm going to say set background color. And I'm going to make it a kind of, let's just try some numbers, see what comes out. Okay, we've got a kind of grayish green background. So there you go. Okay. So there are other things we can draw. We can draw polygons, we can draw lines. Generally, these shapes aren't very interesting. Your game will hopefully not be drawing boring shapes, they'll be drawing images, right? You'll be using your own assets for your game. But these shapes are important because they make great placeholders before you put your assets in. And they're also useful for debugging. Okay. So I'm going to cut out some of this code. I just want my rectangle again. Just the white rectangle. So now we're going to go on to using some variables in our code. So I'm going to write a new function called love.load. So this function is similar to love.draw in that it's another callback function. So someone else is calling this function for us. And in this case, love.load gets called exactly once at the start of the game, right? So when we load up our game, this function gets called once. And inside this function, I'm going to create a few variables. I'm going to create an x, and I'm going to call it 50. I'm going to create a y and call it 300. I'm going to create a w and call it 85, and an h and call it 100. So this is how you define variables in Lua. Lua is dynamically typed, and you'll see that I don't have to provide any explicit types for any of these variables now. And I'm going to use these variables later. So in this case, let's replace the parameters of love.graphics.rectangle with these new variables that we've just created and see what happens. So I'm going to run the game. And the result is the rectangle is now in the position specified by these variables, right? We are just using the values of these variables later on in our code. So one slightly weird thing that you might notice is that we defined these variables within a function call, and we used them inside another function call. And what you'll see is that the default scope of variables in Lua is global. So we create a variable inside this function call, and it now is available everywhere else inside our code. So the fact that variables in Lua are global by default can be problematic. And all I'd advise you to do is use the keyword local wherever you can. So local just means that the scope of the variable is restricted to the scope that you're in. But in our case, we actually want the variable to be global, so we're not going to make a local variable. So I'll introduce you to some of the types in Lua. So these variables here at the moment have the type number. We can change their type later if we like. That's obviously how dynamic typing works. And I've actually shown you another type without telling you. This type here was the type string. That's how you define a string, with a pair of inverted commas. Okay, so it's time to show you the third and final key callback function that Love has. This one is love.update. And this one is slightly different in that love.update has one parameter. We'll just call it dt for now. We'll get back to that later. So again, another callback function. And inside this function, I'm just going to put one line of code. I'm going to change this x value here. And in fact, I'm going to add 1 to it. I'm going to say x equals x plus 1. So what this should do is whenever this update function gets called, we should add 1 to the variable x, right? So let's run it and see what happens. Okay, so what's going on? Obviously the x is being changed quite often. This function, love.update, is getting called a lot, right? And the fact that we could see the result of that, the fact that we could see the rectangle moving, tells us that love.draw is getting called often as well. So in fact, love.draw and love.update are being called 60 times a second. They're being called in a loop. And this is the game loop. This is like the core of a game. The fact that we update state, we do logic, and that we output the results in a loop, that forms the basis of pretty much any game. So to introduce you to a couple of terms, so one iteration through this loop is referred to as a frame usually, and our game is going to run at 60 frames a second. This is like a standard value to use. And I'm going to tell you about this parameter here that I introduced you to. So dt stands for delta time. It's telling us how much time has passed since the last time that love.update was called. And this is how we can make things happen at sort of specific rates, right? Okay, all right. So I'm going to run this again and just remind you what's going on. We've got a rectangle that's moving across the screen. At the moment, this is not a game. This is essentially just an animation. So to be more like a game, we want to be able to tell the rectangle where to move. We want to control it with user input. It'd be good, in fact, if I could control it moving up, down, left, or right using the arrow keys on my keyboard. So that's what I'm going to show you how to do now. So to do that, we need this x equals x plus 1 to only happen when the right arrow key is being pressed down. So I'm just going to block out a conditional. So I'm going to introduce you to conditionals in LÖVE. So we're going to say if, and I'm not going to put in any condition for now. I'm just going to leave the condition blank. So I'm going to say if something, then, oh no, then x equals x plus 1, and end. So what should the condition of x equals x plus 1 be? We need to look at the state of the keyboard, right? We need to query whether the right arrow key is being pressed down. So doing that is really easy. It's just one function call. I'm going to call the function love.keyboard.isDown, and then I'm going to supply a string right, and that's going to check whether the right arrow key is down. And I'm actually going to change this now so that it's more interesting to x equals x plus 4. I'm going to make the rectangle move a bit faster. So when I run this, our rectangle no longer moves until we press the right arrow key. Okay, so we've got some kind of control over the rectangle. So the next step is to add another direction to this. To do this, I'm going to change the conditional that we've got to add a second condition, right? I'm going to say else if. So this is a construction you're probably familiar with. I want to check whether the left key is down this time, but I only want to check whether the left key is down if the right key isn't down. So if the right key is not down, then let's check the left key. So love.keyboard.isDown left. So this time, instead of adding to x, we want to subtract from x. So we've got control over two directions of the rectangle now. So let's run it. And we can now move the rectangle left and right. So I'm going to leave it to you now to add the other two directions, up and down, and I'm going to do them now as well. I'm going to leave that up there. So if you like, you can go and change these to use WASD. I should tell you that the string that you pass in has to refer to like a specific constant. How did I know that right maps to the right arrow key? The answer is I read the documentation. The documentation for LÖVE is really good, and one of the things it includes is the set of key constants to use. So what string should you supply to refer to what key? Okay, so the next thing I'm going to do is a little bit of refactoring. So what you'll notice is that I've got 4 variables here which kind of all refer to the same thing. In this case, they all refer to our rectangle, almost a player at this point. So we want to encapsulate this data into one record, into one structure, into one object. And to do that, I'm going to use a table. LÖVE has this type called a table that lets you do that. So I'm going to create a table. To do that, you give a variable name and you say equals and then curly braces. That's how you create a new table. So I'm going to say player is a new table. And then I'm going to set these values to be values of the player. So player.x equals 50, player.y equals 300, player.w equals 85, and player.h equals 100. And I also have to update like the rest of this code, right? So that's what I'm going to do. But you guys can do that too. So you'll notice that the way we access these variables within the table looks an awful lot like member access of a class. And it's not really member access of a class. This is just something to point out that when I say this is a table, it really is a table. It's a hash table. And this syntax here, .x, is really shorthand for player x, right? And what this, so you'll see that what's actually going on is we are looking up the value in the hash table associated with the key, which is a string x, right? And that's kind of confusing. It has kind of weird syntax. We don't really need to worry about that, except to understand it later, I guess. For now, we can just look at this as though it's a record or a struct and treat this as member access. And we'll come on to another use for tables later. Okay, so once we've done this and run it, nothing should have changed at all. If something has changed, then something is wrong in your code. And once that's working, it's kind of time to give the player a goal in our game. So the goal I want the player to have is that they have to go and pick up a coin. So let's create another table to represent the coin. And once I've done that, we also need to draw the coin in love.draw. So we're going to use the same function. We're going to draw a rectangle, but this time we're going to use the coins values. And when we run that, we should have the player and a coin on the screen. Obviously, it doesn't look like a coin, it's just a rectangle. So at the moment, I can move the player around and I can go up to the coin and touch the coin, but nothing actually happens when I touch the coin. So we need to add some logic for what should happen when we touch the coin. Yeah, let's do that. Okay. So we need to be able to tell when the player is actually touching the coin. Doing that is that process of telling whether two things are touching is referred to as collision detection. And in our case, we're specifically interested in two rectangles which are aligned to the x and y axes. And this kind of collision detection is called axis-aligned bounding box collision detection. And or shortened to AABB. So I want to write a function now which tells us whether two rectangles are colliding. And this is a function which is very reusable. There's no reason why it specifically refers to a coin and a player. It could refer to any two rectangles. So I'm actually going to use this as a chance to show you how writing code in multiple files works in LÖVE. So I'm going to create another file within our directory. And I'm going to save this one as collision.lö. Just collision.lö. And we're going to put our code for the collision detection inside this file. So I told you that this axis-aligned bounding box collision detection is also called AABB. So I'm going to give the function the name AABB. And it should take two rectangles. So remember, a rectangle, we can specify it with a position and a size. So an x, a y, a width, and a height. And we need two rectangles, so that's what I'm going to do. And I kind of don't want to bore you with the geometry of it, but just trust me when I say it's fairly straightforward, and I'm just going to write out the logic that you need. So what this function is doing is it's going to return a Boolean value, it's either true or false, whether the two things are colliding. And the way that we're going to determine whether that's true or not is with this condition. And you'll see I've used the logical AND here. And another point is that LÖVE doesn't care about white space, so what I've written is completely the same as this. But I just put it onto 2 lines. Or, well, 4 lines because it's easier to read. Okay, so we've got our function. It's inside our new file. Okay, I know what I'm going to do. So, okay, now you can read that while I move on, if need be. Okay, so now we need to get that code from this new file into our main file. And doing that is really straightforward. We use the keyword require, followed by a string, which gives the file name. We don't have to specify that it's .lua because we're asking for code. So just require collision. And this is just going to do a textual copy. It's going to copy everything that's in collision.lua into main.lua. And you'll see that this is a lot like an include or an import statement in other languages. And the reason that I've done this, even though it's not really necessary, is because working with multiple files is something you will probably do if you want to make a game that's bigger than like nothing. And it's a good way of showing you how you can sort of modularize your code a bit. Okay, has everyone got that collision function written down? AABB. Has everyone got that? Okay, all right. So we've now got a function which can tell us whether two rectangles are intersecting. It's time to actually use it. So I'm going to say if AABB, and then I need to give the values for the player and the coin. So if the two are colliding, we want to do something. Wow, this is long. Okay, so we're going to pass in all the arguments. And if that's true, what do we want to do? For now, I'm just going to add something to the position of the coin. Let's say coin.x equals coin.x plus, call it 50. So we're just going to move the coin slightly when we touch it. And let's see if anything works when we do that. Okay, there we go. It's working. So when I touch this coin, it moves a tiny bit. And now it's off the screen, it's gone. So you'll see, just to recap what the logic is, we're testing whether the two are colliding, and if they're colliding, then we are moving the coin. So this thing of just adding to the coin's position isn't very interesting. It would be cool if every time we touch the coin, it moved to a random position, for example. So to do that, I'm going to use a library function from the LÖVE math library called math.random. So we want to set the coin's x to a random value, and we want to set the coin's y to a random value. So the function call for that is math.random, and then you supply it with the minimum value and the maximum value to use. In our case, we'd like the minimum to be 0. That's the lowest coordinate. And I should tell you now what the size of the screen is, so we know where we should be putting the coin. The screen size is 800 by 600. So the maximum value we want for the coin x, let's just put it at 800 for now, and we'll come back to that. And similarly for the y, we're going to give it a maximum of 600. Okay, so once we've done that, we should run it. And every time we touch the coin, it should move to a random location. There's something kind of weird and subtle, though, that you might not notice unless you run the game several times, which is that every time we run it, it's not really moving to a random location at all. It's moving to exactly the same location, which is sort of weird, right? We asked it to move to a random location. It's moving to the same location. So why is that happening? The answer is because we haven't seeded the random function. So what do I mean by that? So when we ask for a random number from math.random, it's actually just producing the next number in a deterministic sequence. And we need to start that sequence at a completely random point. Otherwise, every time we run the game, the results produced are going to be the same. So to start that at a random position, we need an actual source of randomness. So I'm going to seed the random function in love.load. I'm going to call math.randomSeed. And the source of randomness that we're going to use is the time. And what this is going to do is it's going to use, I think exactly what it does is it uses the exact millisecond. So the chance that you run this game at the exact millisecond of the same second is like impossible, right? So once we've seeded the random function, the random values produced should actually look random. And if we run our game, yeah, okay, the coin has moved to a different point. And this is a good point to show you that we said the maximum value that the x position should be was 800, and we've got a rectangle which is basically off the screen. So we don't really want the coin to go right up to the edge of the screen. So where I've said 800, I'm actually going to change that to 800 subtract the coin's width. And for the height, the y position, I'm going to subtract the coin's height. And now the coin shouldn't end up off the screen at all. And I'm going to go and add this same bit of logic here to where we initialize the coin, so that initially the coin is at a random position as well. Okay, all right, it's ready to move on. So the next step is having, we've got one idea, mistake. Did everyone copy my mistake and get an error, by the way?
Yeah.
Yeah, okay, if you did copy my mistake and get an error, the reason you got the error is because we were using a variable that hadn't been defined yet. And yeah, so all I've done to get rid of that is to give the coin a width and a height before we actually use the width and the height, because that's a sensible thing to do. Okay, so what we've got is a player and a coin, and the coin moves randomly when the player touches it.
So you're seeding after using the
Oh, good point, yeah. Okay, all right, let's make the random seed the first thing we do. Fine. Okay, we have a coin, it moves randomly when the player touches it. Let's add some more coins. To do that, I'm going to come on to the second use of tables that I told you we were going to come on to earlier. And this is where tables get really weird. We've seen them used as basically objects, and now we're going to use tables as though they were arrays. So instead of having one coin defined at love.load, I'm going to create a table called coins, and this is going to be the table that holds all of the coins in the game. So when do we want to add coins to the game? Right? We want to add coins randomly. So to do that, we need some kind of random probability, not quite a coin flip, but we need something to occur with a random chance. So we're going to use the random function again to use it almost like a coin flip. And I'm going to show you how we use the random function in a different way. So before we were asking for, here we've got a call to math.random where we're getting a random integer within a range. But if we call math.random without any arguments at all, it's going to give us a random number between 0 and 1, uniform random number. So we can use this almost like a probability. So we can say if math.random is less than some very small amount, call it 0.01, then we want to add a coin to the game. So this condition will be true with probability 0.01, right? Okay. So how do we add a coin? We've got the code here for creating a new coin. So let's copy this. So let's create a new coin. And I'm going to use the local keyword because it should be local to our scope. And then we need to add it into that table that we created earlier. So to add it into the table, we're going to call the function table.insert. And we provide table.insert with the name of the table, which was coins. And then the second argument is the thing we want to add to the table. In this case, this table here called coin. So it's a little bit confusing. We've got a table called coin, we've got a table called coins, and we're using them in completely different ways. But don't worry, this will work fine. So we're going to add this coin to the table of coins. So now we need to make some other changes to our code. We no longer have one coin, we have lots of coins. So we need to change all the places where we're doing collision detection with a coin, and we need to change the places where we're drawing the coin to actually draw multiple coins instead. So to do that, we're going to need to use a loop. We need to loop through all of the coins that we have. And I'm going to show you how to use a for loop for that. So here, the code that was checking whether we should, whether we're colliding with a coin, we want to do this for every single coin. So I'm going to say for, can you read that? For I equals 1 to the number of elements. this is some weird syntax, but the way that actually let's add one. Okay. So this is how you open a for loop in LÖVE. You specify a variable, you give it a starting value, an ending value, and the what you add, the step to use essentially. What do you add to that value I every loop through? And in this case, we want to look at every single element in coins. So we start at 1 and we add 1. And that's an important point. In LÖVE, arrays start at 1. Okay, and again, this bit of syntax here, where I've used the hash symbol, this is telling me how many elements there are in the table coins. So we're looping through the table of coins. For every element, we need to first, let's get a copy of the element. Let's say local coin equals coins I. This is how we access that element. We'll check whether it's colliding. And this time, instead of moving that coin randomly, let's remove it from the game. Okay? So let's replace this code here with the code to remove that coin. So I'm going to say table.remove, and then the name of the table, coins, and the index, in this case I. Has everyone got that? So there's a bit more work we can do before we can actually see the coins. We've got to use a loop again, but this time to draw the coins. So I'm going to copy that loop down here to love.draw. And I'm going to replace this code for collision detection with the code for drawing the coin. And then we should be done. And if we run it, we start with no coins, and suddenly, oh, wow. Yeah, I like that error. Okay. Did anyone else get an error? Has everyone run this and got that error themselves? Ugly, right. Why are we getting an error? What are we doing wrong?
What's the error?
So the error says attempts to index local coin a nil value. So in this case, we're accessing elements of coin, except coins I was nil. Can anyone see what the problem is? Yeah.
I'm guessing that if you have 0 coins, number of coins is 0, it tries to move from 1 to 0.
Okay.
And ends up with a single.
Do we have 0 coins?
No, we don't.
No. So we did. So hang on, wait. We had something weird happen. We didn't get an error for one of the coins. Yeah. Okay. Second. Yeah.
Sorry.
All right. Okay.
You remove.
Yes.
You remove. Remove the coin from the list. Now it becomes shorter than what it was before.
Yes. Yeah. Okay. So for anyone who didn't hear that, the problem is that we are looping over this array and also removing elements from it. So this is like a common pattern. We often want to loop over stuff and then remove elements from it. And the way to fix this is instead by just looping from the end of the array to the beginning. So instead of our starting value being 1, our ending value being the number of coins, and our step being 1, we're going to start with the number of coins. We're going to end when we get to 1, and we're going to step in steps of -1. So now we're going to loop from the end of the array back to the beginning of the array. And if we run this, we shouldn't get any errors at all. Crossing my fingers. Okay, suddenly it's working, right? So now that we're looping in the right direction through the array, we can actually remove these coins without any problem. Okay, so let's add a bit more logic to the game. Let's keep track of how many coins the player has picked up. So I'm going to create a variable in love.load called score. I'm going to set it to 0 initially. And then at the point where we know we've picked up a coin, the point where we're removing the coin, I'm also going to add to the score. So I'm going to say score equals score plus 1. And we need to output this score on the screen somewhere. So I'm going to introduce you to another drawing function, this time called print. So I'm going to say love.graphics.print, and I'm going to provide print with the thing to print, in this case just the score. And I'm going to tell it where to put that, and I'm going to make it in the top left of the screen, X10 and Y10. No, don't open that. So you can barely see that at all. Can anyone see that number in the top left corner? That's so tiny. So that text is kind of crap. We'll fix that later. Okay. And also, this is a good time to show you one more function of strings in LÖVE. So I don't just want to print the number score, I also want to say this is your score. So I'm going to write the string score, and then I want to combine these two things. I want to combine the text score with the actual value, and to do that we're going to use the concatenation operator, which is 2 dots. So when we do this, now it should say score 0. Still crap text though. Okay, right. So this is a good point to just take a quick look at what we're doing in our game. Just a quick recap of everything. First thing we're doing, the first thing we're doing is we're including all the code from this file, collision, and we wrote that collision section code. We're seeding the random function. We're creating a table for the player and setting some initial variables. We're creating an array for the coins, and we're creating a variable for the score and setting it to 0. In our update function, we're doing player input by checking the various arrow keys and then updating the player position accordingly. Then we're looping through all the coins, and if they're colliding with the player, we're removing them and adding one to the score. And then, with some low probability, we are randomly adding coins to the game. And in our love.draw, we're drawing a rectangle for the player, we're looping through all the coins and drawing a rectangle for each coin, and we're printing out the score. So the logic for the game we're going to make now is done. The rest is the actual exciting stuff, the stuff that makes it look like a game, and that's assets. So I've actually created a set of assets. Well, that's not quite fair. I haven't created the assets. I've collated some assets freely available from the internet into a zip file, which is available if you head over to the notes page now. So the shortcut to get there again is hackers@cambridge.com/love. So that should take you to the notes page. And there's a link right at the top there for the assets. So if you download these assets, you should get a zip file. And what I'm going to do is I'm going to take the zip file and drop it into our game directory. And then I'm going to unzip it. So now within our game directory, we've got a new folder called assets. Okay, so inside this assets folder, you'll see there are a bunch of different things, and we're only going to use some of them now. Okay, so now let's actually use some of those assets. We've got those assets in the same directory as the one we're in. So first of all, let's do some sounds. Let's have a sound effect for the player picking up the coin. So to do this, we need a sound object, and getting a sound object is really easy. First of all, I'm going to make a table for all the sounds we might want to use. Sounds equals a new table. And I'm going to say sounds.coin equals love.audio.newSource. And then I'm going to give it the path to the file for the coin sound effect. And that's going to be assets sounds coin.org. And there's one more parameter I need to tell it that the sound is static. Okay, all right. So once we've written this line is sufficient to load the coin sound effect into the game. The next step is actually playing the sound effect when we want it to play. In our case, we'd like the coin sound effect to play when the player picks up the coin. So let's go to where the logic that should occur when the player picks up the coin is here. And let's say sounds.coin play. So I'm going to run this. We should get when a coin appears. There we go. Okay. Okay, all right. I was complaining about the font size earlier, so this is a good time to load a font as well. So similarly to what I've done here for the sounds, I'm going to load in a new font. First, I'm going to make a table for all the fonts we might want to use. And I'm going to just make a font called, let's call it fonts.main, or let's call it fonts.large. And let's load in the font, love.graphics.newFont. And the place where the fonts are is under assets, fonts, and then the font we're going to use is called gamer.ttf with a capital G. And then the second parameter for new font is the size to use. And I'm going to say 36. And we should get, no, I forgot to actually use the font. Okay. So we've loaded the font. The next step is for that to be set to the font to use when we print something. So here where we've got love.graphics.print, I'm going to say love.graphics.setFont, and then fonts.large, which is the font we made earlier. And when I run this, it should work. There we go. Okay. A slightly more reasonable size. Is everyone sick of that sound yet? So now I'm going to show you how to use some images. The first, I'm going to create a table for all the images again. And let's just use an image for the background first. So I'm going to say images.background equals love.graphics.newImage. This is how we load a new image. And then again, we just specify the file name. So let's have a look at our directory again. We have assets, images, and then ground.png. So assets/images/ground.png. So once we've done this, we've loaded in the image. And now we need to draw the background. So I'm just going to start by drawing one of these background images. So to do that, I'm going to call love.graphics.draw. and then the name of the image that we've created. So let's have a look at it again. Images.background. So I'm going to draw images.background, and then I need to specify the position with which to draw it. And let's just put it at 0, 0 for now. And I'm going to run it. And there we go. Okay, we've got, you can see we've kind of got like a stone tile, but we've only got one. And we sort of want it to cover the whole screen, because otherwise it's not really the background. And we could stretch the image, but if we stretch it, it's going to look awful and stretched. So instead we want to tile it. We want to draw the same image lots of times to fill the whole background. So doing that is a little bit confusing, I guess. It's dependent on both the screen width, the screen height, and the image size. So I'm just going to write out the loop to do this, because it's fairly straightforward. So we need to loop through the whole x. So from x 0 to the width of the screen. To do that, it's love.graphics.getWidth. So we're going to go from 0 all the way up to the width of the screen. And the step size to use is the width of the image. So images.background getWidth. Okay, so that should loop through the x. And we also need to loop through the y. So for y equals 0 to the height, love.graphics.getHeight. And in steps of the image height. So images.background getHeight. And just notice I'm using that's a semicolon, not a full stop there for getWidth. Okay. And once we've done that, we should draw the image at the position x, y. And when we run this, we should get a fully tiled background. Okay. So I'm also going to use an image for the coin, but this should be really straightforward because you guys know how to load and draw an image now. So I'm just going to do the same thing again. I'm going to say images.coin is a new coin. Why the colons?
Yeah, as opposed to dots.
Yeah, so using the dots is the way that the split stuff up into kind of modules. Yeah, so for example, when you use a map.random, random is a function which is a member of a map. Right? So you're just accessing this map. That's why it's the reason you're using a colon is because now you're using the image or whatever it is as an object. And there's it relies on LÖVE meta tables, which I don't want to get into. Think of it as calling a member function versus calling like a static function. So we are calling getWidth on the background. We're getting the width of the background. Whereas any other time we used just a dot, we weren't actually referring to a specific object. Okay, so we've got the code for loading the coin, and now we're just going to replace, where we're drawing a rectangle for the coin, we're going to replace this with drawing the coin image. Okay, so this is looking a little bit more like a game. I think it would look a lot more like a game if the player weren't a rectangle but were actually a player. So we now have access to these 4 images for the player. So now let's use just one of these. I'm going to load in an image for the player. I'm going to say images.player down equals love.graphics.newImage. And and I'm going to put in the place where I put it, which is images player down .png. And then instead of drawing a rectangle for the player, we're going to draw that new image. So when we run this, there we go. We have a player. He doesn't turn in any direction, he just kind of slides around. But you've now got those 4 images, so if you like, you could write some logic to work out which direction the player ought to be facing based on the last input that they pressed. So just as an example, I'm gonna start writing some code for that. So I'm gonna say player.direction equals down initially. And then let's just in one place change it. So if the person putting the input in, the player, wants to go right, so this is the bit where we're going right, I'm going to say player.direction equals right. So I'm just going to give you a model for how to do this, but I'm not going to write all the code for it. And then instead of drawing the same image for the player every time, I'm going to just create a copy for it. I'm going to say local image equals images player down. And then I'm going to say, actually, if the player's direction is, what did I say? If the player's direction is right, we'd rather that image were images.playerRight. Okay? And then instead of drawing the same image every time, we'll just draw the local copy that we've created. Right? Does that make sense? So I need to, first of all, load in player right as a new image. And I also, let's also make sure that if the player is actually going down, we'll set their direction back to down. So what we're doing, we're storing a value for the player's direction. When the player changes direction, we're updating that value. And when we come to draw the player, we're choosing the image to draw based on the direction that we want. So let's change this. So if the player direction is right, then go right. Else if the player direction equals down, then the image should be player.down. Okay, and I'm going to run this. Oh dear. Oh dear. Oh yeah, good spot. Yeah, okay. I made the classic mistake of equality checking and variable setting. Right. So I'm going to run this, and we should now have 2 directions which we can use. You'll see that left and up don't work, but right and down do work. Okay, so obviously you could go and use that for all 4 directions for the player if you want. But actually that's where I'm going to leave things for this like small demo example game. And I'm going to take this as a chance to show you a slightly more advanced version of this same game that I've created for the workshop. So let's start with what is different. We've got a title screen. It's not hard to implement a title screen, don't worry. We've got music, that's just a sound effect that's playing in the background. We've got a timer that's ticking down that gives a player a limit on how long they can play for. You'll notice that the coins actually disappear now after a certain amount of time, and they flash before they're about to disappear. And instead of just using a static image for the player, we've got a kind of animation, right? There we go. And so we've got a title screen, a play screen, and a kind of game over screen that shows you what your final score was. So There's also like a couple of other more subtle things that you might not notice, which is this window is resizable. That's something that you wouldn't have been able to do originally. You'll notice that the window has a title, it's called coin, and it has a little icon down here, a coin image. So logically, I haven't really changed anything except for adding a timer, but you'll see that there's a lot of enhancements I've made around sort of having a title screen and having more assets like music and animations. So the code for this is also structured quite differently. I've structured it less like what we were writing today and more like how I would be writing a larger game. And I encourage you to take a look at the code for this if you're interested, because it's I don't want to say it myself, it's a model for how you might want to make a love game. So the source is available. If you go back to the notes page again, there's a link to all the source code for this, along with the assets and the code, and you can see how I structured it and take a look at what exactly I've done. Okay, so aside from that, I just want to wrap up really. I hope you'll agree that LÖVE is quite easy to use. I mean, we started off today without even having LÖVE installed, and after an hour and a half, we've all made kind of a very simple game. So I think that because LÖVE is so easy to use, it's perfect for making games quickly, and that's fundamental for prototyping. And I also want to stress something else, which is we've only really scratched the surface of what LÖVE can do. LÖVE is really powerful. There's tons of library support for LÖVE, so anything you can think of, you can probably implement it if you like, so long as it's not 3D. The community is really good. If you need help, you can go online and find help. It also has fantastic documentation. So going back to the homepage for LÖVE, just follow this link to the wiki, and you'll have all the documentation for all of the functions that we use today. So if we go and have a look at LÖVE.graphics, we'll have a list of all the functions that come under LÖVE.graphics, so we can have a look at LÖVE.graphics.draw, and oh look, there's actually a load of other parameters we can use that we didn't use today. So I think LÖVE is great. I hope everyone learned something today. I hope you guys had fun. Thank you very much.